A tiny Pro Touring style RC car with a detailed engine bay, full interior, warm glow lights, lifelike solid axle rear end, and chassis twisting 3S LiPo power. Is this super scale model the best of both worlds? Let's have a closer look at this 1/24 scale 1970 Buick GS. Hello everyone and welcome! Today I'm back with a vehicle that attempts to combine great scale aesthetics with relatively high performance small scale RC electronics. Is it the perfect blend of scale and speed, or does it come up a bit short? Well, that's for you all to decide. In my opinion, I think it hits the mark pretty well, but in today's video, my goal is to give you all a detailed look at this car and show all the parts it took to build it. I'll talk about everything I like, a few things that might need a bit of work, and some stuff I think's worth considering for any fellow hobbyists out there. But without any further introductions, let's get this custom-built Buick onto the bench and get started. The life of this Buick began not with an unboxing, but rather flipping the switch on a 3D printer. Well, actually, it did sort of begin with an unboxing, as I am using a plastic model kit from Monogram as a donor for the body and some other stuff, but that just doesn't sound as cool. My point is, some assembly was certainly required. And by some assembly, that includes 3D printing the chassis, soldering all of these tiny electronics, and modifying a plastic model kit that was designed to spend its life collecting dust on a shelf, not be strapped to an RC chassis. With that said, this project does require having a bit of experience with model building and custom RC projects to ensure the best results in the end. While performance and relative durability was part of the equation for this build, I'd still say it's best to approach a project like this more with the mentality of building a detailed model of a vehicle that just so happens to be fully drivable, more so than building a high-performance RC car that just so happens to look very lifelike, if that makes sense. Now, if you've been following some of the builds I've showcased on this channel prior, primarily the super scale plastic model to RC conversions, you know that while often a great amount of lifelike detail is present both on the outside, inside, and even underneath, the performance often isn't exactly much of a priority, and as a result, these cars aren't exactly the most exciting RC vehicles to drive by just about any metric. So the idea here was to try and maintain as much of the scale detail as possible while making the car a little more exciting to drive around the track. It's not the fastest RC car in the world, but in my opinion, it's got a good balance of scale and speed. Obviously, this model car isn't going to handle crashes too well, so at a certain point, higher speeds do start to get a bit scary. But with all that said, I hope the information I'm able to provide in this video is helpful to anyone interested in doing a similar project. Let's start with the body, which I've sourced from a Monogram plastic model kit. This kit originally dates back to 1989, and overall I'm extremely impressed with the detail and fitment of all the parts. An all-around great kit which has been reissued pretty consistently over the past few decades. This here is the 2012 reissue, but more recently it was reissued in 2022. Obviously, the latest issue of this kit will be very easy to find and is probably the one to get, as it includes a number of optional parts to customize this Buick. It looks like you could build sort of an 80s or 90s era custom that I think looks pretty cool, but I'm sure it's not quite to everyone's taste, so of course you can also build a stock 1970 GSX. The GSX was in some ways sort of the ultimate muscle car in terms of both luxury and performance. Built between 1970 and 1972, they were the highest performance variant of the Buick Skylark. Every GSX came with a 455 cubic inch V8. In 1970, the Stage 1 performance package was optional, boosting horsepower to 360 and offering an unmatched 510 foot-pounds of torque. In addition to all that power, the engine was also significantly lighter than other big block V8s of that time, roughly 150 pounds lighter than a contemporary Chrysler 426 Hemi or Chevy 454 big block, and only about 25 pounds heavier than a contemporary 350 cubic inch small block Chevy. If properly equipped and with the right conditions, the 70 GSX was capable of 0 to 60 times at just a little over 5 seconds and could do the quarter mile in the mid-13s. Certainly competitive, if not outright blowing the doors off of most other regular production muscle cars of this era, all from the comfort of a plush, well-equipped Buick. High-performance vehicles might not be the first thing you think of when you think of a Buick, especially today, but taking a look at their history definitely reveals some real gems, the GSX being no exception. Now you may have noticed with this car that I built here, I actually sort of detuned the body, if that makes sense. When it comes to the real cars, you'll often see lower trim models of vehicles such as the Chevy Chevelle, Ford Mustang, or Buick Skylark being modified to look like higher end trims, such as the SS454, Shelby GT500, or GSX. Usually these are referred to as clones, replicas, or tribute cars. You get the look of the top-of-the-line model, but technically it started life as a more ordinary mass-produced variant. In the model world though, usually kits are replicating whatever the highest performance or most famous variant of that car was. Lots of fastback GTs and Z28s, not very many inline-six base model configurations. So sometimes model builders will detune or debadge or base modelify, whatever you want to call it, to make the car look like a lower trim version. This may be done for a number of reasons. For example, if you're building a replica of a car you actually own, for example a two-door 1970 Skylark, well, this model kit here isn't going to be a perfect match, it's close enough to at least be a good starting point. You can remove the hood vents, which wouldn't be included on a base Skylark, not include the spoiler, make a few tweaks here and there, maybe have to do a bit of custom building in spots, such as the grille, but overall, you'd at least have something close to start with. It may also be worth checking to see if there is a conversion kit somebody makes that lets you convert one plastic model kit into a similar but slightly different car. For example, turning this AMT 1970 Camaro kit into a slightly later 1974 model year. But basically, since I figured I was doing a custom build and wouldn't be replicating the yellow or white paint job that these cars came with, I figured I'd change things up a bit and make it look more like the lower trim GS rather than the GSX. Now, I'm no expert here, so it might not be entirely accurate, but again, this is a custom Pro Touring style car, so it wouldn't exactly be uncommon to see mismatching parts in the real world on a 50-something-year-old car like this. But to make the hood look more like it's from a GS, I didn't install the GSX's hood-mounted tachometer. There was a spot in the hood where it would fit into. I filled that with some putty and sanded it smooth. In addition to leaving off the tachometer, I also didn't install the front or rear spoiler. There's no holes or anything in the rear that the spoiler fits into, so no need for any modifications there, and the front spoiler is part of the chassis piece included in the plastic model kit, which I didn't use. The only other part of this car that I changed was the grille. This was partially because the GSX emblem was molded in as a part of the grille, which wouldn't have been the end of the world if I left it as it was, but I thought it would be cool to try and give this car a little bit of a custom look and actually make the grille see-through. What I did was just carefully take a rotary tool and grind it down the back of the grille. Eventually it was thin enough that I could just cut it out with a hobby knife and then glue in some wire mesh. And now I have an easy custom grille that I think looks pretty cool, and I'm really happy with how it turned out. As far as additional modifications go, I needed to cut a little bit of material out around the inner fenders. Fortunately, I didn't need to remove them entirely, just needed to make some room for the FC01 front suspension assembly. Being that this is a custom Pro Touring style car, I decided rather than using the engine included in the model kit, I would instead 3D print my own LS V8. I do want to point out that this LS engine piece is the one part of this project that I 3D printed, which I have not posted the STL files to on our Patreon. The reason for this is we did not create this 3D model, so obviously we don't want to be distributing it without permission. I've had this STL file for many years, and I don't recall where I got it from, but I'm sure if you search 3D models or 3D print files of LS engines, you'll find something that you can use. I'm sure there are also a ton of 1/24th and 1/25th scale LS engine kits, though of course they'll probably need some modifications to fit around the RC motor. Another option is that you can use this engine piece which I created, and I used most recently on this 1985 Pontiac Trans Am. Obviously that file is up on our Patreon. It's not an LS style V8, it's just sort of a generic older style carbureted engine, but it's easy to print and looks pretty good. I guess the point here is that while I unfortunately can't share this exact STL file, which admittedly isn't really amazing anyways, you certainly have options if you're looking to do something similar. This engine didn't have any sort of tubing beyond the throttle body, so despite the steering servo kind of being in the way, I just ended up cutting a little piece of shrink tube and glued that onto the front. Hey, it works, right? If it doesn't quite look scale enough, just squint your eyes a little. Overall, despite not being a super detailed engine bay, I'm still really happy with how it looks overall, and I think it definitely adds to the look of this car. As you can see, I have added lights to this body. Just as I've done with some prior projects, I sourced some tiny Pico-sized LEDs from Evan Designs. I've got warm white lights in the front and red in the rear. And yes, there are supposed to be 4 lights in the rear, not 3. I don't really know what happened to that one on the far right, but I really don't feel like swapping that out at this point, so I'm just gonna leave it. As I've said before, that's one of the joys, in my opinion, of building older cars, as you can get away with little imperfections like that. But aside from that little blemish, I'm really happy with the installation of these lights. I just drilled a few holes, glued them in place, and then soldered them all together, making sure to use a resistor since they're being powered by a roughly 12-volt 3S LiPo. I obviously don't want them to burn out, but I also don't want them to be too bright. In my opinion, super bright LEDs on a model like this hinders more than it adds to the appearance of a car. I'd like to come up with a way to spread the light more on the taillights to help make it look a bit more like the real thing, but I'm really happy with how the headlights turned out. Wasn't sure whether to just do the outer headlights or also add LEDs to the high beams as well, so I guess tough luck to all of the oncoming traffic that goes past this car at night, but I do like the look of all these lights illuminated. No side marker lights or turn signals or dashboard lights, nothing like that, but maybe something for a build in the future. On the inside, the wiring for the LEDs is probably the roughest part of this whole car. Originally, I was just planning to use a plug like I've done before, but I thought I'd give magnets a try so that way I don't have to worry about unplugging the LEDs every time I want to take off the body. Magnets are usually how I secure the body anyways, so it was pretty easy just to solder the wires to the magnets. Obviously just make sure positive to positive, negative to negative. Unfortunately, as you could see, I did have some trouble getting them to make good contact, so I ended up having to add a little bit of solder to help bridge the gap. Probably the right thing to do in this situation would be to try and solder like a tab of some kind, something like you'd find on the bottom of a slot car that has some spring to it, so it would make better contact with the magnet above. Obviously though, the idea here is pretty simple, completing the circuit with magnets rather than a plug. Is it a superior method? Well, that's for you to decide. As long as you get everything lined up and making good contact, I think it's a good way to go. Now there's nothing too special or extraordinary with regards to the interior. No custom parts or modifications, I just built it exactly as instructed. But I think just the fact that this car is able to fit a full depth, unmodified interior is pretty cool. Using some reference images, I went with a white interior that I think pairs really nicely with the exterior color. Now at least with the images that I was looking at, the carpet, center console, and dash was black, with everything else being white, and I think it adds a nice bit of contrast and helps that interior to pop. But not really too much to talk about here, a little spray paint and a little detail painting with a brush, glued everything together, and it fit in the body perfectly with no modifications being required to accommodate the RC chassis. Like I said, I'm really happy with this model kit, definitely one I would be interested in building again. Now to anyone interested in building a similar car to what I have here, keep in mind the bigger the body, the better. This particular 3S LiPo battery that I have here just barely fits in the trunk. I really couldn't find anything on the market that's smaller. You could always use a 2S LiPo instead, but if you want to run a 3S, I highly recommend going with a body that's at least similar in size to what I have here. I imagine a similar car like this 1/24 scale Revell 1970 Pontiac GTO would be just as good of a fit, but unless you can find a smaller size 3S LiPo, I think you're going to really struggle to do what I've done here with a smaller pony car or sports car. Of course, you could just hack away at the interior if you need more room, but obviously what I wanted to do here was have as minimal sacrifice to the scale realism as possible. Just something to keep in mind, but overall a really fun build, and I'm super happy with how the body turned out. But now let's have a look underneath and talk about the RC chassis. For regular Make It RC viewers and builders, just about everything here should look familiar. This is our FFR SC1 chassis design, an FDM 3D printable RC car chassis, great for 1/24th and 1/25th scale plastic model to RC conversions. It features a front motor rear-wheel drive layout with a solid axle rear end. An easier to 3D print and assemble FFO1 front suspension and steering assembly is optional, however I decided to install one of our FC01 assemblies. The double control arm suspension of the FC01 will likely require a smaller size nozzle when 3D printing, and it is a bit more of a challenge to assemble due to these very small size parts. However, if you're up to the challenge, the result is a very nice, scale-looking setup that works great and can be quite durable when built correctly. Though of course, as with anything this small and detailed, you do have to be careful to avoid crashing, which can result in damage. This suspension design can be adapted for use on a custom frame or one included with the plastic model kit, just like I did for that 39 Chevy Street Rod build. If you're using it with a FFR SC1 chassis, a frame piece such as this can be used, allowing the steering servo to be positioned up front rather than behind the front wheels. Obviously, this has the advantage of not requiring any modifications to be made to the interior piece to fit around the steering servo. Optional parts for the FC01 include a brake rotor and caliper. A cool thing to add if you'll be installing larger, more see-through wheels like these. Just make sure there's enough clearance between the caliper and the wheels that you choose. Not all wheels that we have available will fit with the caliper in place. Since I have those good-looking disc brakes in the front, I wanted to put some in the rear as well. There isn't a specific spot on the MA10 rear axle housing that these are designed to be mounted to, but I just lined them up and glued them to the housing, as you can see here. I think it looks great, though not exactly increasing the serviceability of this axle, as they are blocking a couple of tiny screws, but hey, it's a compromise I'm willing to make for scale realism. If you're a longtime viewer of this channel, you might recall a 2010 Shelby GT500 that I built previously. These wheels here are the ones that the car had when I initially built it. I've since swapped them out for some higher detail resin 3D printed wheels, but despite these here just being a simple FDM print, I think they look great on this car. Now, something a little bit unusual to note is that the rear track width is slightly narrower than the front. When you're going through the STL files, you'll notice we have two different width MA10 rear axle housings, a 53mm and a 57mm. Normally you would match the width of both the rear axle and the front suspension. On this project though, I was just sort of reaching into the parts bin, and I didn't notice until I was part of the way through the build that this was the narrower 53mm axle in the rear, while up front I've got a front suspension assembly designed to match the 57mm axle. So as a result, the rear track width is a bit narrower compared to the front. Yeah, it's kind of noticeable, but it really doesn't bother me. I just figured I'd roll with it as is. To me, the slight difference in width isn't really a big deal, but just thought I'd mention it. Normally, I could slap on some additional spacers in the rear to better match the front, except as you can see, I'm out of threads on that axle shaft. When you're building your own car, it's really just a matter of getting things to fit and look right. Of course, it's always a good idea to do some measuring, but there's not really any magic or science to it. Just kind of mock things up, see how everything looks, and go from there. This project isn't exactly a Tamiya kit or a Lego set where you can just kind of follow each instruction step by step exactly as shown. When you delve into the realm of custom RC building, you're responsible for getting the chassis lined up with the body, modifying the body to fit, and get everything to look as good as possible. As I've shown in some prior videos, one of the things that you need to watch out for is ensuring the front wheels can steer without coming into contact with the body. Here I needed to do a little bit of massaging on this front corner of the front fenders to make sure that the wheels won't rub when steering. Some careful sanding with a rotary tool, and now as you can see, there's no issues. Clearly, I don't always do this, but in a perfect world, it's better to make any modifications such as this before painting the body. Usually if you're careful though, it's not a huge deal. Speaking of steering, note the orientation of this piece here. By having this ball joint further out than this ball joint on the control arms, this results in a better steering angle versus the orientation that you see on this car. A way better angle, but sometimes you do have to have the ball end more towards the center of the vehicle in order to fit the wheels that you want to use. Since performance was a consideration with this vehicle, and this Buick body is relatively wide, I was able to space the wheels out and ensure I'm using wheels that allowed for this better orientation. Also, make sure that the tie rods are as close to a straight line as possible when the steering servo is centered, to ensure you're getting the most amount of steering angle. A little bit of paint, especially on those calipers and rotors, really helps improve the appearance of this chassis. Sure, it's never going to look as good as if you're able to use the chassis piece included in a plastic model kit, as I've done with some of these prior projects, but not bad, and using a 3D printed chassis like this does make the build process quite a bit easier. So an FFR SC1 chassis with an FC01 front suspension and steering assembly, both designs that have been showcased on this channel numerous times before, but you might have spotted something a little bit different here right in the center. This main chassis piece is fully adjustable. While we've always offered numerous different sizes to accommodate wheelbases from 100 to 135 millimeters, this very simple design modification allows infinite adjustability. What was previously a one-piece main chassis is now available as a two-piece. 4 2mm steel rods connect each part, which can be slid to whatever wheelbase you need, then cut and glued. In this case, I chose to make the wheelbase about 118mm to fit this particular body. Of course, I could have just done some measuring and then 3D printed a 118mm main chassis piece specifically, but I can see how some people may prefer this method of precisely adjusting the chassis to fit the body, like maybe you really need a 118.5mm or you want to build a stretch limo. I don't know, but hey, it's an option now. Something that can't be seen but is important to point out is that I decided to install brass ring and pinion gears in this axle. Since I'm going for performance here, I want to ensure that the drivetrain is up for the challenge. So in addition to these FDM 3D printed drive shaft ends with these metal dowel pins that go right through them, I also installed the brass MA10 gears. For the lower speed, super scale plastic model to RC conversions, like these I've showcased prior, the resin gears will do just fine, as long as properly installed. They're much cheaper than the brass set, but anything that's going to be raced around or driven more aggressively than just cruising around on a smooth surface, in my opinion, brass gears are probably worth the investment, as you just install them once and you shouldn't have to worry about them again. The plastic model body will probably get totally wrecked before the gears would ever fail. If you're curious about the price, stay tuned as I'll be going over what it costs to build a car just like this a little later on in this video. Now for your convenience, I've gone ahead and put all of the STL files for the 3D printable parts I used for this project into a single folder you'll find over on Patreon. You'll notice I have included the option to choose a wider 57mm rear axle that better matches the front track width, since as I said before, I sort of accidentally went with a narrower rear end than the front. Just wanted to make that clear, but obviously at the end of the day, it doesn't necessarily make a huge difference whether you choose an axle that's a few millimeters wider or narrower, but I felt like it would be a good idea to go ahead and include arguably the proper size rear axle. And you probably already know this, but just to be clear, we have tons of different size components available on our Patreon. I've just conveniently gone and put the parts I use specifically for this car into a separate folder onto a separate post. But if you find that these parts aren't really fitting your project, we do have quite a number of variations available, so just keep that in mind. Obviously, over there you'll also find much more information, videos, and tutorials, which will show you how all these components go together. There's also links and more information about the non-3D printable parts that you'll need, such as the hardware and bearings, most of which we have kits available for on our website. But I hope all that information isn't too confusing or overwhelming. Honestly, I think some of the best advice I can offer is really just tinker, experiment, and build stuff. Figure out what you think looks the best and be diligent throughout the building process to ensure everything is functioning as it should. If you're embarking on a project like this where you're 3D printing your own parts, these small pieces literally cost pennies to produce unless you're using some really expensive filament. Inexpensive PLA is what I use. It's plenty durable for small on-road RC models like this. I don't store or use these cars in extremely hot environments, so there's no worries about the plastic deforming. Obviously, when you're diving into the realm of custom RC projects like this, it's going to be more difficult than simply building a kit step by step, piece by piece. But with that said, I do want to point out that we have some more simple chassis designs and already 3D printed kits available both on our Patreon and our website. The building experience of these will be more of a follow-along step-by-step type of build, at least as far as putting together the chassis. For example, our FPUC1 chassis is a platform I've showcased many times prior on this channel. While obviously lacking in scale detail, it's a very durable and fun to drive platform, and a great way to get started in this niche of the RC hobby. I just wanted to point this out for folks who might find this project interesting, but either don't have access to a 3D printer or are looking for something a little easier to build, certainly something to consider. I'll link a couple of recent videos showcasing this 68 Corvette and this 85 Trans Am. Both of these projects were built with chassis that we have kits available for on our site if you don't have access to a 3D printer. Definitely check out those projects if you're interested in doing something similar. Still not necessarily something I would recommend to a hobbyist with zero model building or RC experience, but certainly a lot more simple and straightforward of a project than this Buick that I built here. Without a doubt, something like that Corvette build would be a great way to get started in this niche of the hobby, and you can always start to work towards more and more detailed builds as you gain more experience, just as I've been able to showcase over the years that I've been making these videos. It certainly doesn't happen overnight, but I feel like I'm getting better and better with each project, and I'm sure that'll be the experience for anyone else, no matter what you're building. But I think that just about wraps up what I wanted to say with regards to the chassis, at least as far as the mechanics. Of course, if you have any questions, please feel free to send a message, but let's go ahead and move on to the electronics. As I've done with prior projects, such as the 65 Shelby GT350 and this 39 Chevy Coupe, I tried to select some of the smallest sized electronics as possible in order to make more room for details such as the interior and engine bay. On those prior two projects, it was basically all about scale realism, but here with this Buick, I wanted to focus a little more on the performance without sacrificing too much with the appearance. If all I cared about was maximum speed, I'd be brushless swapping a small-scale basher or a Lexan-bodied race car, not messing around with the plastic model kit. That said, I think I've got a pretty good balance here. There's a lot more power while still keeping the electronics hidden. Rather than being powered by a 1S LiPo, this Buick is 3S LiPo compatible, thanks to the slightly larger but still compact ESC. It's capable of sending more power to the motor, but the 3S LiPo is too high voltage for these tiny receivers and servos that I like to use. I decided to add a small adjustable voltage regulator that can send the correct voltage to these other components. With this in place, I can ensure that the receiver and servo won't get cooked. Speaking of the servo, I'm using the same more powerful all-metal gear servo that I used prior for that Jeep J10. It's a bit faster and more powerful than the servos I usually use, so I figured I'd install it into this more performance-oriented Buick. Links to all of the electronics, as well as the other non-3D printable parts used, have been posted on Patreon. As far as how to wire all of this together, it's pretty straightforward as the sellers of all these components provide the necessary information. At some point, I think I'd like to do a detailed video geared more towards beginners on how to wire all of these electronics together, but right now I'll do my best to give you all a simple overview. I want to preface this by saying to always consult any instructions or information provided by the manufacturer. I'm just showing you what I did here, but please double check everything you're doing to ensure nothing gets fried. Once the smoke leaves, it's not going back in. Alright, so I know it might look a little bit messy, but hopefully I can kind of explain how all this goes together. Really, it's pretty simple and straightforward. The hard part is just getting everything to fit and soldering these tiny connections. This here is the ESC, this is the receiver, and this is the voltage regulator. The motor and steering servo are obviously on the front of the chassis. Now I believe this ESC works on a voltage range of about 3 to 14, so you can use a 1S, 2S, or 3S LiPo. The battery gets plugged in here, positive to VCC, ground to ground. On the opposite side is where you solder the wires that go to the motor. Very simple and straightforward. The N20 motor I'm using can go up to 12 volts. The steering servo and receiver, however, cannot. I'm dropping that down with this voltage regulator, positive to positive, negative to negative, straight from the battery. These wires here, in case you're wondering, are for the LEDs. You'll probe this end with a meter and adjust the potentiometer until the voltage is where it should be. In this case, I got it to about 4 to 5 volts, so I wouldn't be overpowering the steering servo. So coming off of the lower voltage side of the regulator, positive to VCC, ground to ground. To enable this receiver to control the ESC, I went from channel 2, which is the throttle on the transmitter, to PWM, pulse width modulation, on the ESC. I then connected the ground on the receiver to the ground on the ESC. With that done, I can control the ESC with this receiver without overpowering the receiver. And then to power the steering servo, red to positive on the low voltage side, brown to negative, and then yellow to channel 1 on the receiver. Looks a little messy, I know, but it all works, and hopefully that explanation is helpful. Of course, be sure to consult any information provided by the manufacturer. Hopefully, at the very least, for those with some prior RC electronics experience, this explanation is helpful for anyone wanting to do a similar setup to what I have here. I chose a 4,000 RPM N20 size motor, since in my opinion it offers a great balance of torque and speed while being very small and easy to cover up with a scale engine piece. That said, this car is running on 3S, so you could definitely put something a lot spicier under the hood if you wanted. Just keep in mind you may need to devise some form of gear reduction if you're having trouble with getting enough torque. As you may recall, I've encountered that issue with prior projects such as that 78 Trans Am, which I cured with essentially a magnetic torque converter of all things. But yeah, if you wanted to go faster, you certainly can, but these little N20 motor and gear assemblies are reliable, torquey, and don't take up much space. But enough chatting on the subject, let's do some driving. This Buick is probably one of the best driving and fastest FFR SC1 based vehicles I have. The top speed of this 4,000 RPM N20 motor might not be super high, but it doesn't take long to get there. Plenty of torque and quick acceleration. The low speed modulation is also very good, allowing the car to drive around smoothly at slower speeds. That all-metal gear steering servo might be pricier and take up a bit more space, but it's quick and durable, ideal for driving at faster speeds. That FCO1 front suspension and steering assembly is working great. This car tracks straight, and when it's time to turn, it has a very tight radius to get around sharp corners. Hopefully one of these days I'll be able to build a proper track for these 1/24th and 1/25th scale models, but even in these confined areas, it's still a lot of fun to drive, and I guess all of these bumps from this indoor track are good for testing the suspension, right? Now, is this model car going to be running down Mini Zs or other high-performance Mini RC race cars? Certainly not. Even with more power and a higher top speed, Keep in mind this platform uses a solid axle rear end, and there's no differential in there to let the outer wheels spin at a higher speed in the turns. Does it make driving fun and the car more interesting to watch as it squats and struggles for traction? Absolutely, but that locked rear end isn't going to help with traction in the turns. Of course, more speed often means more problems. There was a little bit of carnage during the test drive, but that's just part of the hobby, and it's to be expected when driving cars this detailed and relatively fragile. I'm super happy with how this car turned out though, and I'm definitely looking forward to doing some more driving and builds using these same electronics. I want to briefly talk a bit about what a project like this might cost and some of the tools that are required. This tends to be a pretty frequently asked question, so hopefully I can help provide some insight. First, I'd like to highlight this video here that I made a while back, where I go over all of the tools that I use for these types of projects and some of the tools that I would recommend to beginner hobbyists. As I've said before, I'm not a brand loyalist, I don't sell tools, I'm not sponsored, and you're not going to find any affiliate links below in the description. So if you're asking about what brands I recommend, or where do I think you should buy all your tools from, I really don't have an answer for you. Buy whatever you think looks good, see what has good reviews, that type of thing. I can tell you that at least when it comes to the tools I use for these model builds, about 80 to 90% of them were purchased purely on the basis that they were the cheapest thing available on either eBay or at my local store, and just about all of them are still working just fine. So that's my mentality anyways. I wouldn't necessarily apply that same line of thinking when working on other things, but for these RCs, I think it's fine. For more expensive items though, like a 3D printer, definitely do your homework and not just settle for whatever's the cheapest. But anyways, go check out that video if you're interested. But aside from the more ubiquitous tools that just about any hobbyist is going to have in their toolbox, you'll definitely need a good soldering iron for soldering all of those tiny wires into place. It's also a good idea to have some good solder and flux. That can definitely make things a lot easier. And of course, for this project, you'll also need a 3D printer. Now, all of these parts are designed to be relatively easy to 3D print on a typical hobby FDM type 3D printer. While it seems that these printers are continuing to become better and more affordable with each passing year, 3D printing is still a bit of a hobby in and of itself, and may require a bit of fine-tuning to get the part quality you want. I get a lot of questions asking what 3D printers I recommend, and really it depends a lot on what your budget is and what your printing requirements are. I primarily use a lot of older Maker Gear machines, but those are quite old and I'm not even sure they're still being made. While certainly not the cheapest options out there, I've heard a lot of great things about Prusa printers. I know a lot of our customers and Patreon members use Prusa machines. I've been really happy with the Creality K1 I've had for probably about a year now. However, that's not a printer I would necessarily recommend if you're going to be printing a lot of tiny parts like what's here on this chassis. You really need a small size nozzle to print these tiny parts accurately, and you may need to mess around with and fine-tune the settings to get the best result. It's not like there's any magic or single trick to getting a perfect print. You just need to be willing to take your time and experiment, research, and tinker until you get the desired result. Things like the nozzle size, the flow rate, the speed you're printing at, the temperature, stuff like that. A lot of these parts can also be made using a resin printer, which prints objects at a much shorter layer height and produces much more detailed parts such as these. I haven't really done that much resin printing with these particular parts that I use for this chassis, mostly because I really wanted to design them in a way that could be printed on an inexpensive, ordinary FDM type printer. But I imagine you could have success using a resin printer as well. Probably the only disadvantage I would see is depending on the resin you're using, they might be a bit more on the brittle and rigid side, so you may need to be extra careful when building and driving. Finally, you'll also need a multimeter, specifically for dialing in the output voltage on that step-down regulator, but really it's just a very handy tool to have for a lot of things. For example, it's a great tool for diagnosing issues such as you can check for continuity between 2 points or ensure you're getting power to each component. Also nice for checking batteries. It's a tool I'm sure a lot of you already have, but it's definitely worth the investment, especially since you can get them pretty cheap. Now, as far as what it would cost to build a Buick like this, I've put together a rough breakdown, including shipping to the USA. Again, I have links posted on our Patreon to the specific parts that I purchased for your convenience. Obviously though, if you're outside of the USA, things might be different. Keep in mind this is just a rough estimate, not including the cost of any tools required, the FlySky GT3B transmitter, or the 3S LiPo battery, which I already had on hand and I can use for various other projects, not just this Buick specifically. but both the transmitter and this battery can probably be purchased for around 50 bucks. Although this is probably more on the expensive end as far as the plastic model to RC conversions I've showcased on this channel in the past, it's probably worth keeping in mind that by RC standards, this amount is pretty low, even for something in this smaller scale. But that said, you could definitely do a model car to RC conversion for something well within the $100 to $200 range, or even less if you already have some of the items that you like to use, such as a battery or a plastic model kit. Now, in my opinion, in general, if you're on a super tight budget and you don't already have tools and parts, honestly, the mass-produced, ready-to-run electric RCs are probably a better way to go rather than custom building something. This is because you know exactly what you're going to need to spend to get everything up and running. I know the ready-to-run vehicle costs exactly this amount. Maybe I need a battery and charger to go with it, but no special tools or supplies. Just buy the vehicle, charge up the battery, that's it. On the other hand, when you're custom building an RC, no matter what it is, you might find that you need to order some additional hardware. The battery you thought would fit doesn't, so you have to order another one. You accidentally fried one of the electronics or broke something. Stuff like that is just far more likely to happen when you're building something custom from scratch. So as a result, the exact total can be a lot harder to pinpoint, if that makes sense. Now, it certainly can become less expensive to build something rather than buy a ready-to-run or even a kit if you've been in the hobby for years and you already have a stash of parts, a stash of hardware, and all of the tools on hand. Maybe you even have some old vehicles that you can cannibalize for parts. If that's the case, you could theoretically build something for no cost at all. Look, my point is everybody's situation is going to be different, but just something to keep in mind as far as getting a rough idea of the cost. Again, it's hard for me to give exact numbers here, but hopefully this at least gives you an idea of what a project like this might cost. Basically, my one-sentence answer is a few $100 at a minimum for a 1/24th to 1/25th scale plastic model to RC conversion. Can it be done for way less? Absolutely, but I figure better to overestimate and have money left over in the end. I hope you all enjoyed today's video, despite it being a little different from some of the recent content I've posted. Unlike with some of those prior projects where I recorded the entire hours-long build process, which I then edited down into one of these full build videos, the build process of this Buick was not recorded. So as a result, today's video is more of a showcase of the finished result, rather than a more complete overview of the entire build process. I hope you'll forgive me if some of these future projects coming in 2025 are presented more in this way, a thorough look at the finished model and me rambling about it for a bit, rather than a more detailed look at the entire assembly process step by step. I've got a lot of great projects coming up in 2025, many of which will be covered in far more detail, just as I've done in some prior videos like with these projects here, but in order to increase the amount of builds I'm able to do this year and help maintain my sanity, I've decided to cover some of them step by step, while others will be more of an overview of the finished car. I still want to do my best to make these videos as entertaining and informative to all you builders out there as possible. And like I said, I've got numerous other videos, including detailed tutorials covering how to assemble both the FFR SC1 chassis and the FCO1 front suspension and steering assembly. So if you're wanting to build a chassis like this, there are videos that I've made which you can follow along step by step. But certainly a lot of cool stuff in the works. It's just that some of these projects I plan to cover in more detail than others. As I've said, I'm really happy with how this Buick turned out. Great looks, fun to drive, a good test bed for these electronics, and really not much drama, just a pretty straightforward project. I certainly hope you all enjoyed this video, and any fellow builders out there found it helpful. If you're interested in doing a similar project, check out the links below in the description. But that's all I've got for today's video. As always, thank you all very much for watching. Whatever you're working on, best of luck to you, and of course, I'll see you next time. Stay tuned to see what's next.